This meeting is being recorded.
Professor, what are the notes for today?
Chapter 7.
It wasn't there 2 chapter 7s? Is there 2 chapter 7s?
1 chapter 7. And
So it's the same from last week?
yes, it's the same file.
Oh, all right. Thank you.
Okay, let's go ahead and begin. Okay, Cassidy,
Here.
Alejandro, Liliana, Lainey,
Here.
Cassandra Diaz, Romeo Diaz, Viviana Duarte, Brenda Escalera,
Here.
Jasmine Garcia,
Here.
Josue Garcia,
Here.
Jade Gomez,
Here.
Valerie Gonzalez,
Here.
Edsel, Joel,
Here.
Monique,
Here.
Salvador,
Here.
Caitlin,
Here.
Kayla,
Here.
Romeo Ramos,
Here. Also, Alejandro just joined.
okay. Paola,
Here.
Aaliyah, Ricardo,
Here.
Matthias. Okay, one last time. Alejandro,
Here.
Liliana, Cassandra, Romeo, Viviana, Edsel, Aaliyah, and Matthias. Sounds good. Okay, well, today we're going to continue in chapter 7. Today is 7.5, possibly go into 7.6. We'll see how things go. Okay, so here are the notes for 7.5. Okay, so we're going to start 7.5 and talk about loans. Okay, in this section, we will discuss conventional loans, also called amortized loans or installment loans. Some common examples include auto loans and home mortgages. These techniques do not apply to payday loans, add-on loans, or other loan types where the interest is initially calculated. The nice part of this section is that the loan formula is the same as the payout annuity formula, which we didn't cover. I'm not covering this in this class. Okay, so here's the loan formula. It looks like a pretty complicated formula. Once you start using it, it's not as complicated. Okay, P naught is the initial balance in the account. So this is the present value, what we call present value. Okay, I'll just write this over here. This is the present value. Okay, D is the payment amount. How much is your monthly payment going to be if this is paid out in months? Okay, so this is your payment. Okay, R is the rate, is the annual interest rate, okay, or the APR. Okay, K is the number of, so K is the number of payments per year. And N is the length of the loan, and that's in years. So, okay, years of the loan. Okay, putting it all together. Okay, again, I'm not covering this. So the loan formula assumes loan payments are made on a regular basis, each month, year, quarter, etc., and includes interest in each payment. How does this compare with the other formulas? Compound interest, one deposit, remember the compound interest formula, A equals P times 1 plus R over, we'll use their notation here, K, times KT, or K times N. We'll do NK. Okay, using their notation. This is the compound interest formula, and it contains a bunch of elements from this. Okay, just rewritten a little differently. Okay, so in the compound interest formula, we don't have D because we're not making payments. It's one deposit. Okay, one deposit or one payout. Okay, so. And then loans, many payments, that's the formula up above that we're going to start utilizing. Okay, let's start utilizing this formula. Okay, race car Rita can afford a monthly car payment of $250. Okay. After some research, race car Rita found a bank that offers a 5-year loan at 7% annual interest. If she chooses to take this loan, how expensive of a car can she afford? So we want to know what is the initial amount that she can take out. So that's P naught that we're looking for, D times 1 plus 1 in parentheses, another parentheses, 1 plus R over K to the negative NK all over R over K. Okay, so let's pull out the variables and identify the variables that we have and the ones that we're looking for. Okay. So P naught, that's the present value of the loan. This is the loan amount. Okay, and we don't know that. That's what we're looking for. D is the payments. Oh, what are the payments here? She can afford a car payment of $250 a month. Okay, so $250 a month. Okay. What about R? What's the interest rate? Well, the annual interest rate is 7%. So that's going to be 0.07. Okay, what about K? K is the number of payments per year. K is the number of payments per year. Thank you, Paola. Okay, so if it's a monthly payment, then how many payments are there per year? Yeah, very good, 12. Okay, and then N is the number of years. How many years? 5, right? Okay, 5. Okay, so we're going to put this all together. Okay, and we're going to say, P naught is equal to 250 times 1 plus 1 plus, or sorry, 1, is it plus or minus? I think it's minus, yeah. It should be minus. Minus 1 plus R over K. Well, R was 0.07. K is 12. This is to the negative 5 times 12. Okay, all over 0.07 over 12. Okay. Okay, I might rewrite the negative 5 to the 12. Negative 5 times 12 is negative 60. But other than that, I'm just going to kind of keep everything. This is negative 60, right? Okay, I'm going to keep everything the way it is, and I'm just going to plug directly into the calculator. Okay. Okay, so I'm going to use my calculator here. And I'm going to say that I have 250 times, first parenthesis, 1 minus, second parenthesis, 1 plus 0.07 divided by 12, close the first parenthesis, raised to the negative 60th power. So I'm going to go 60 negative. Okay, and then I'm going to close the second parenthesis. Close parenthesis. Okay, and then I'm going to hit equals. Okay, that gives me 73.65 about on the top. Now I can take this number and I can divide it by what's on bottom. I'm going to take this number, I'm going to go divided by, okay, parenthesis, 0.07 divided by 12, close parenthesis, equals. And that tells me that I can afford, she can afford, a $12,625.50. $12,625.50. Okay, that's how much she can take out for a loan. Oh, did it not show? I'm sorry. Yeah, absolutely. I guess I'm not sharing my screen correctly. Let me do the stop sharing. Okay. There we go. Okay. So let's clear this again. Okay. And I'm going to say that this is 250 times first parenthesis 1 minus second parenthesis 1 plus 0.07 divided by 12, close first parenthesis. Now I've got to raise that to the negative 60th power. Raise that, and I'm going to plug in 60 negative 60th power. Okay, I'm going to close the parentheses, and I'm going to hit equals, and that's going to give me the top value. Okay, it's going to give me the top amount of 73.65, I guess I should say. Okay, now I'm going to take that and divide it by the bottom amount. So divide by 0.07, a parenthesis for open parenthesis. Divide by open parenthesis 0.07 divided by 12. Close parenthesis equals. Okay. Were you able to get that amount? Okay, awesome. Good job. Nicely done. Okay. Paula, were you able to get the correct amount? Oh, perfect. Awesome. Okay, yeah. The hardest part of this is going to be plugging in the numbers correctly. Okay, cool. Yeah. Okay. What is the total loan amount including interest? Now this is interesting. Okay. So this one's actually a pretty easy calculation because how many payments does she have to make and how much are the payments? Well, the total loan value, this is how much she's going to have to pay out in total. Is going to be 250 payments, the amount per payment, D, okay, times NK. And what was NK? NK was the total number of payments. Total number of payments here is 60. Right? So I have to pay out $250 a month for 60 months. Well, that's the total loan amount. Oh, okay. So I just multiplied 250 times 60. And that's 15,000. So she will end up paying out a total of 15,000 over the life of the loan. Okay, over 60 months. Okay, she can only purchase a $12,625 vehicle right? Okay, what is the total interest that she will be paying? How much interest would she pay? If this is the total amount that she's paying out, and this is the interest, okay, Okay, 15,000 minus 12,000, 625.50. What we call it, we say this is the loan value. This is the loan value minus the principal. That's the amount that I'm borrowing, is going to be equal to the interest. So the interest here, if I subtract this, okay, 2,374.50 cents. Yeah, exactly. Thank you, Cassidy. Okay, so minus 12,625.50. Is that right? Yeah, 2,374.50. Okay, 2,374.50. Nice. So if you ever have to buy a car, okay, this is how you know what you're supposed to be paying, and you're not getting taken advantage of. Okay, so good mathematics here. Okay. So now there are apps that will do this. Yeah, to get a loan, they have to check your credit. Okay. Anything over 700 is exceptional credit. Anything between 600 and 700 credit is okay. Anything below 600 is considered bad credit. So credit scores range from 200 to 900. So credit ranges from 200 to 900. Most people fall, the average credit score out there is about 650. Okay, 650 is average. Okay, so anything from 600 to 700 is considered okay. Okay, once you get above 700, you're pretty much good. You can get a loan pretty easily. If you're below 600, you're considered a risk. Okay, it means you don't pay your bills on time. Okay, but this is where you want to live, right here. Okay, and then they'll give you a nice. Then they'll this is the minimum place that you want to live. Okay, and then what you really want to do is get up here, but it's pretty hard to get up there. Okay, you have to be borrowing a lot of money and paying it off rather quickly. Okay. So hopefully that helps with the credit, so credit score. Okay. Wait, again, you just keep in mind though that the people who, like, once you buy a car or you buy a house or something, you really don't need a huge amount of credit, because you never want to borrow more money than you can pay back, because that will lead you into problems. So say somebody gives you right now a $3,000 credit card. Well, if you go out and spend all that $3,000 and then they're saying, well, you need to pay $300 a month on that $3,000. Well, how are you going to pay that back if you don't have that $300 a month? Right? How are you supposed to pay on that credit card? So you never want to borrow money. Like people who have good credit are ones that borrow money and then pay it back real quick. Okay, they borrow other people's money and then pay it back real quick. But you never want to extend those payments out too long, otherwise that kills your credit score, and it puts you in a really financially kind of devastating position, because once you can't afford your monthly payment, then you're screwed. So it's better to try to take this money and put it into a savings account and wait. It's called delayed gratification. Put that in a savings account and then wait 6 months and then get, whatever that you want to buy. right? If you saved up, $200 a month for 6 months, you'd have $12,000, and then you wouldn't have to charge it on a credit card that's going to pay you. That the credit card is going to be at like 29% interest. It's a really high interest loan. It's really bad. 29% interest. So a ton of interest. 130 or money is going just to interest. So really bad. So and you never want to go above half, just to let you know. If they give you a $3,000 limit, say that they give you even a $500 limit, because when you start with your first credit card, they're only going to give you $500 because they don't trust you. And you never want to go above half. Okay, you always want to stay below half. If they give you 500, then the most that you want to charge at one time is 250. Exactly. Okay, so don't ever go above half. But if you do charge this 250, then it's easier to pay off. And then once you pay off it, your credit will go up. So that's how you start building credit. Okay. So you start building credit by saying, oh, okay, I charge this, Nintendo Switch, and now I'm going to pay it off, by doing maybe $50 a month. Put yourself on a budget, $50 a month, boom, and in 5 months you'll have that Nintendo Switch paid off, and then you can go out and make another purchase and pay that off. But don't ever, but the trap in credit cards is they'll give you more money than they know you can pay back. And it's a trap. Okay, they'll be like, you'll get this in the mail and you'll be like, oh, you have a $2,000 limit. Well, it doesn't matter if I have $1 million limit. That doesn't mean that I can afford to buy $500,000 worth of stuff. Not at all. You give me as many credit cards as you want. Does that mean that I have the ability to pay it off? No, I don't. So, but this is where young college students get trapped. They're like, oh, they gave me a $2,000 limit. Yeah, well, that's great, but maybe you only have the capacity to pay off $1,000, in a month's period. And certainly, if you don't have a job, if you have no job or no income, do not get any credit whatsoever. You're not credit worthy, even though lenders will give you stuff, and then you just end up paying 10 times as much for your things as if you had just saved a few months and bought it cash. So anyway, that's my use credit wisely speech. Okay, better to hear this as young as possible than to end up 30 in debt and having to file bankruptcy. Okay, so not good. Okay, Lazy Daisy purchased a $300,000 house with 10% down and financed the rest at 6% annual interest over 30 years. What was her mortgage payments? Okay, let's use our formula, our handy dandy formula. Okay, P naught is equal to D times 1 minus 1 plus R over K, okay, to the negative NK all over R over K. Now, with one caveat in that, what's P naught going to be? P naught is not equal to $300,000. Why? Because I was smart and I saved my money. And most lenders want you to have 10% down on a house. So you have to say, oh, well, I'm going to be smart and I'm going to save my money, and that I want 10% down. So what's 10% of 300,000? What's 10% of 300,000? Well, if you do 0.10 times 300,000, then you multiply that together, you get 30,000. So I would have to have $30,000 in the bank. Okay, maybe, borrow it from a relative or something. $30,000 in the bank. So am I going to finance all $300,000? No. What am I going to finance? I'm going to finance the total cost of the home minus the $30,000 that I put down. This is minus my down payment. Okay, is going to be equal to $270,000. Oh, okay. So that is my P naught. Okay, so it's 30,000 less than why? Because this comes directly off the top. That comes directly off the top. Okay. That's what I give the bank to say, hey, I'm good for the loan. So then we have $270,000 is the loan amount that I want. Okay, and I want to know what's the monthly payment. So I'm going to have to solve for D this case. I don't know what D is, but I do know what the interest rate is. The interest rate was 6%. And I make monthly payments. And so what's 12 times 60? I'm sorry, what's 12 times 30? 12 times 30, 12 months for 30 years, right? 12 months, 30 years. That's 360 payments. Does that make sense? 360 total payments, all over 0.06 over 12. Let me clean this up just a little bit. Let me get D times 1 minus 1.005. That's 0.06 divided by 12. Okay. Raised to the negative 360th power, all over 0.005. Okay, and that equals $270,000. So now how do I solve for D? Well, you see this thing right here is a fraction. Okay, this thing right here, not including the D, is a fraction. Does that make sense? That's a fraction there. So I just want to solve for D. D is being multiplied by this huge fraction. So what I'm going to do is I'm going to multiply both sides by the reciprocal. Okay, I'm going to multiply both sides by the reciprocal. So when I do that, this side's going to cancel out because the bottom is going to get canceled with the top, and the top is going to get canceled with the bottom. And then D ends up being 270,000 times 0.005 over, right? Multiply both sides by the reciprocal. 1 minus 1.005 to the negative 360th power. Okay. Okay. We're going to say that this is approximately, okay, clear. Okay, let's plug this into our calculator properly. I'm gonna save the 270,000 for last, okay, to multiply that, because that's just gonna be an easy multiplication. I'm gonna do the division here first. Okay, so 0.005 divided by parentheses, first parentheses, 1 minus second parentheses, 1.005, close parentheses, raised to, okay, the negative 360 negative, close parentheses, okay, and hit equals. Boom. Okay. So that's 0.005 or 0.006 basically. Okay, and then I'm going to multiply this number that I got times, okay, 270,000. 270,000. And that comes to be $1,618.70, we'll say 9 cents. And that's the amount, that's the house payment that she can afford. She, I don't know. Oh, Daisy. Daisy. Okay, he, she, they, whoever. Okay, Daisy, $1,618.79. Okay, that's the total payment amount. That's what we call the mortgage payment. Okay. What is the total interest she will pay over the life of the loan? Okay. So this one's a little interesting because, again, how much is she, what is the total loan value? What's the total loan value? Well, the total loan value is the amount, is the payment amount times the number of payments. The payment amount times the number of payments. Okay, this is the total amount that you have to pay back. Okay, not the 270. The 270,000, that's just the principal. Now we want to calculate all the interest. How much interest are over 30 years? 30 years is a long time. Okay, to be paying on a loan. You're going to be paying a lot of interest. Okay, almost half. Almost half of the loan goes to interest. Okay, so what's the payment amount? The payment amount was $1,618.79 times 360 total payments. Right? So let's calculate that out. What's the total value of the loan? This is principal and interest. Okay, clear. So 1618.79 times 360 payments is $582,764.40. Okay, so 582,000. What was it? 764.40. That's the total amount that she would have to pay over 30 years. Okay. Now, what if I want just the interest? What would I do? I would take this amount and I would subtract off the principal that I borrowed. Minus the principal that I borrowed, which is 270,000, which is going to be equal to 312,764.40. So more than half of the money that I have to pay back is interest. That's how banks get so rich. Because they're basically just saying, yeah, borrow my money. Yeah, they're saying borrow my money, and then you're gonna have to pay me back double over 30 years. It's the only way that people are able to afford these houses. You know, these incredibly high-priced houses, especially in Southern California, you know, is to borrow someone else's money for 30 years and pay them double. Okay, now imagine if you were a bank and you were able to do this, but do it all over, you know, lend to thousands and thousands of people. Well, you're getting incredibly richer and richer and richer. That's how the rich stay rich, right? Because they're like, once I have money, I can then lend it out, and I can just make more and more money. Okay, remaining loan balance. Let's move into 7.6 here.
Excuse me, Professor, can you go up just a little bit? I just have to copy one more part.
Sure. Let me go get a drink of water and be right back. Take a water. This is a water checkpoint. Take a water break. Back in 60 seconds. Okay. Let's cover 7.6. Or at least start into it. Okay, it is often desirable to determine the loan balance after some years. For example, if one purchases a home and anticipates selling it in 5 years, one might want to know the remaining loan balance of the amount left to pay from the sale, right? So how much have I already paid and how much is left over that I'm not going to get out? Okay, to determine the remaining loan balance after some years, we need to know the amount of each loan payment. Also remember, only a portion of each loan payment applies to the loan balance. A portion is applied towards the interest, okay, which money you'll never get back out. Warning, if payments were $1,000 per month, the total payments would be $12,000, but $12,000 is not applied to the original loan balance. It's applied to principal and interest. Principal and interest, not just principal. Okay. The good news is that we can use the same formula we've been using in order to calculate this. Okay. So if a mortgage at 6% annual interest rate has $1,000 payments of $1,000 per month, how much will the loan balance be 10 years from the end of the loan? Okay, so 10 years from the end of the loan, right? So we're saying that we don't know what the life of the loan was, but we do know that 10 years from the end, I've got 10 years remaining, and this is 0 years remaining, right? So we're thinking of time as backwards, right? This is the amount of years left. Okay, so 10 years remaining. Okay, then what's the present value of a loan that has 10 years remaining? That's what we want. We want basically what's the present value? What's the present value of a loan with $1,000 monthly payments We don't care how much has been paid off so far. We just want to know how much is left. How much is left on the how much is left when I have $1,000 payment that I'm paying a month, okay, for 10 more years. And again, it's not 12,000 that's being paid off. It's principal plus interest. So it really is just like saying, okay, how much money can I afford to take out under these circumstances? Okay, how much of a loan can I afford if I'm going to pay it off in 10 years? That's basically the same question that's being asked. Okay, at 6% for 10 years. Well, we've already answered a question like that. Oops. Sorry about Okay, we've already answered a question like that. And we're just going to use the same formula, D times 1 minus 1 plus K R over K, the negative NK, all over R over K. Okay. Okay, so let's just plug in and see what we get. Okay, so P naught is equal to D. What's D in this case? What's D in this case? Yep, very good. Thank you, Alejandro. It is 1,000. Okay, it is 1,000. That's our monthly payment. Times 1 minus 1 plus, what's our interest rate?
0.06.
Very good. Thank you, Romeo. Okay, how many payments in a year? How many payments in a year?
12.
12, thank you. Okay, and then how many total payments are there going to be? How many total payments are there going to be?
120.
Yes, very good. Thank you, Cassidy. Thank you, Alejandro. Yeah, it's 120 because it's 10 times 12. Okay, 12 payments a year for 12 years over 0.06 over 12. Again, just plug this into the calculator and then tell me what you get. What do you get for this if you plug this into the calculator? I'm going to simplify this just a little bit because it simplifies. The 0.06 is a nice interest rate to use because it simplifies a little bit. 1,000 times 1 minus 1.005 to the negative 120 all over 0.005. So plug that into a calculator and tell me what you get. Yep. I like that answer. $90,073.45. Okay, this is the amount that's left on the loan. Okay, or the amount that I would have to borrow in order to buy the house at this time. Right? How much money would I have to borrow to pay off the house? That's the amount of money that I have to borrow to pay off the house, pay off the next 10 years. So if I did borrow this amount, if 90,073.45 was borrowed, okay, or how much is the life remaining on the loan? Maybe I'll just say how much, we'll say how much interest is left to pay on the loan in the remaining 10 years. How much interest is left to pay on the loan in the last 10 years? So. Okay. Well, let's see. How much are we, is the principal, okay, is 90,000. What's the total loan, what's the total amount of payments? What's the total loan value? What's the total amount of all the payments for 10 years? Well, that would be 1,000, which is the monthly payment, times the number of payments, which would be 120. So this would be 120,000. Oh, that's easy. So that's how much money I have to pay out of pocket in the last 10 years of the life of the loan. But how much principal is left is 90,000, 73.45. If I subtract those two, I should get the interest. So there's, if I do subtract those two, I get $29,926.55. And that's how much interest is remaining. Okay, so the longer you pay on a loan, the less interest you owe. It's just the way it works out. The way compound interest works. Okay. Let me know if anybody needs more time copying this down. Because I want to show you one last application of this, and then we'll call it a day. So if you do end up buying a car or something that requires you to take out a loan, okay, you're not going to want to do all these calculations by hand. Let me show you some nice apps on the internet, okay, that will do this calculation for you. You can check your results this way as well. Okay. So what it's called is it's called the time value of money calculator. So you might want to even write that down in your notes. It's I'll write it here. Okay. I'm just going to Google time. If I could shift, where's the shift? There it is. Time value of money calculator. See that right there? Time value of money calculator. Nice. Okay, time value of money calculator. Okay, the first one comes up is future value calculator. Okay, free calculator to find the future value. You may not want that one. Okay, TVM calculator. I like this one. This is a TVM calculator. Financial calculators. Financialcalculator.com. TVM calculator. That's a good one. Okay, again, there's a bunch of them that will do the exact same thing. All it's going to do is the calculations that we've been doing, but it's just going to do it for you. So you can whip out your smartphone, and there's even apps for this, and it says, hey, it says, what's the present value? What's the loan amount, right? Say I want to go out and buy a Jeep Wrangler, and the present value that they're saying is, well, that's the loan amount, right? The present value is the loan amount. So I'm going to say, well, I want the loan to be $25,000 out the door, maybe 30. Let's do 30 grand, or 29.5. Let's do 29.5. $29,500. Boom. That's for my new Jeep Wrangler, fully loaded. Okay. Okay. The future value I want to be 0. Right? I want to be 0. Why the future value is 0? Because I want to pay this thing off. Okay. Okay. The annual rate, that's your annual percentage rate. Let's say that we get a loan at, I don't know, 8%, and it says enter it as a percent. Okay. The periods, these are the number of compounding periods per month. This is the number of payments that you're going to pay every month, and I'm going to pay, or every year. So I'm going to pay 12 per year, and then I'm just going to click there. You have to have 4 out of the 5 filled in, okay? and then it will calculate the fifth one for you, which is nice. So if you know any four of these, it will calculate the fifth one for you. Okay, so I'm just going to click payment, and it's a negative. And the reason it's a negative is because, well, what the heck? That shouldn't have worked. Oh, the periods is not 12. I'm sorry. The periods is how many payments. I'm going to do a 5-year loan. So I'm going to do a 5-year loan. So the periods is 60. My bad. Okay, it's not 12. It's 12 times 5. It's not a 1-year loan. It's a 5-year loan. Let's do 60 there. Screwed that up. Okay, 60. And now let's do our payment. There you go. That's a little nicer. And it says, look, on my brand new Jeep Wrangler, I'm going to have to pay $598.15. So again, when you go out to buy a car and you have this app, you know, on your phone, then you just say, hey, I know exactly what I'm going to pay. And then the guy wants to, you know, mess around with you, and you just say, hey, you know what? Okay, then you could lower the interest rate here. You could say, hey, you know what? We could get you a little bit better of an interest rate. A lot of times they want to extend the life of the loan, but that just means you're going to pay more interest. They're going to be like, well, if we go to 66 months, which is an extra 6 months, we can lower your monthly payment by a certain amount. So they'll be like, oh, well, let's do that. Because that makes a whole hell of a lot of sense. It doesn't. Okay, if you can't pay off the car in 60 months, you shouldn't own that much of a car. I'm going to tell you that right now. Okay, if you cannot pay off a car in 5 years, then that is too expensive of a car for you to own. The problem is that everybody wants to, you know, buy these cars that they can't afford. Okay, so let's do 66 months, see what happens when the guy screws me over. That means I'm going to have to pay 6 extra months, but it goes down $50 a month. So they're like, oh, well, I can get this, you know, you're going to have to pay 6 months more, which means you're going to have to pay more interest to me at 8%, but I can lower it, right? And then they're like, oh, well, let's go to 6 years. Let's, you know, the car's not going to be worth much in six years, but you're still going to be paying $553 after 6 years. Again, the car is not going to be, you want to be able to pay off that car in 5 years before any major, you know, major malfunctions start to happen on the car. Because after 6 years, you're going to have after 5 years, you're going to have about over 100,000 miles on that car. You know, especially if you're buying it new, which I don't think I'm ever going to buy another new car, because I can get a used car that's only a few months old because people are stupid. Okay, have like maybe 3,000 miles on it and saves me thousands of dollars over the life of the loan. But it's okay. I mean, if you're young, you want the new stuff. That's fine. I was young and I wanted the new stuff too. So it's all good. You know, it's just people's priorities. But let's go and let's change this to 72. And they're going to be like, in the finance office, they're going to be like, oh, let's give you a 72-month payment, or let's go an extra year where you're paying on this car for an extra year. And they're like, oh, we lowered it to around 500, which is where you want to be. And it's like, no, this is the wrong way to go. You do not want to go this way. This is how they're going to try to screw you over. Okay, you do not want to go this way. What you want to do is you want to go the other way, which is don't mess with the number of payments. What you want to do, you want to mess with the value of the car. Okay, you want to be like, hey, you know what? Maybe I don't want the fully loaded Jeep. Maybe just the Jeep Wrangler that doesn't have all the 4x4 and the lifted with the premium wheels and the navigation. Who needs navigation anymore? I mean, we all got iPhones, right? The hell do we need navigation for? So you're like, hey, you know what? No, buddy, that's too expensive for me. Why don't you lower the price of the car by $4,000? So let's do 25,000 or 24. I don't know. Yeah, 25,000. We'll just do 25,000. let's get a cheaper model, and now let's see what the payment is. Look at that. By choosing a cheaper model, I was able to drop my payment $100. Isn't that kind of interesting? A month. So again, if you ever go, used car salesmen are professional liars. I'm just going to let you know that right now. They are professional liars. That's how they make their money, by lying to people. Okay. And they're professionals at this. And I have bought many a car in my day and had to tell them. And I whip out my calculator. I bring my calculator. This calculator has an application on it for the time value of money. It's right here, apps. Boom. And it's finance. It's my finance app. And I bring my TI, and then when they see me bring my TI-84 in, boom, right? So when they see me bring my TI-84 in, they're like, well, what the hell do you do for a living? I said, oh, I'm a mathematician. I teach financial mathematics. And they're like, okay, I'm not gonna be able to lie to this guy. And I tell them that. I say, you lie to me once and I'm gone. I don't care how much I'm in love with this vehicle. If you lie to me once and I catch you at one lie, I'm done with you. I'm going to another agent. I'm going to another dealership. And that's how I get a good deal on a car. Because they can't screw me over because I know my math. So anyway, any questions on anything? Okay. Exactly. Okay. So smart money. Be smart with your money. Okay. Okay. I'm going to cut it off there for today. We'll finish up chapter 7 on Wednesday. Okay. Thank you for those of you that submitted chapter 5 worksheet on time. I appreciate that. Okay, very much. Okay, see you guys later. Bye. You're very welcome.